All right, then let's get started. Welcome everybody to this week's Gardener review meeting. Today we look at the 1.131 release, and we start with Konstantinos and the Terraformer removal in provider OpenStack. Next up is Radoslav with a valitail replacement with the OpenTelemetry collector. I will give an update about GAP28 and the gardenadm connect command. And finally, Lucas will close it with some new metrics for the extension conditions. With that, Konstantinos, please get started.
Hi. So, let me see my screen. Okay, I hope I'm sharing the correct screen. Then, okay, let's talk about the PR. So, if you've been here long enough, you know that after the original, a lot of the extensions that were relying on Terraform to provision the infrastructure for the shoots. We were discussing a long time to go ahead with the removal from our extensions, and we want to speed it up after the whole VSL change from HashiCorp and so on. And so we create this new implementation for the infrastructure controller, which relies more on the Go native SDKs rather than with the Terraform. And this has been ongoing item for quite some time, and we are approaching the later stages where we had the implementation, we tested long enough, we gradually swapped it to as the default implementation, and now this is the final part of the PRs where we basically just remove the old implementation. So for quite some time we had both implementations going on in parallel, because we want to as a failsafe, and because the infrastructure is a crucial part and we don't want downtime or issue for stakeholders and so on. And now we only have one implementation. So there are not a lot to showcase. I do have a suit here, for example. And if we take a look at the infrastructure for such suit, and we scroll at the end, then we will see that the later part of the state is somewhat different from the previous ones. Previously, we had the base64 encoded state of the infrastructure, of the Terraform state. Now we have some other key data, like IDs and stuff that we use to keep track of. That's mainly your telltale of which implementation you're doing. And I think that should be, so basically this change should be completely invisible to both operators and users. In practice, there are a couple of differences in the implementation, but it should generally be more malleable to the user and not reconcile things that are not intended to be reconciled and so on and so forth. So there should be more hook points for the user. And I think that should be most of it for what changed. Again, it should be completely invisible. If you see issues, then just let us know. We had a couple of bugs already reported for OpenStack because, unfortunately, no two same OpenStack environments exist. And just let us know and we will continue to improve. I can give you back 4 minutes.
Any questions to this endeavor? Nope. All right, then thanks, Konstantinos. And next up is Radoslav with the valitail replacement.
Hey everyone, hopefully you can see me, you can hear me, you can see my screen. Today I'd just like to give you a quick update on where we at with Observability 2.0. The last thing that we successfully merged was actually the replacement of valitail with a collector. This again is part of the GAP34 implementation. More specifically, the PR that replaces valitail with collector. Now, a quick reminder from the last presentation I gave what OpenTelemetry is. OpenTelemetry is a lot of things. It's a standard, it's a protocol, It's a collection of solutions for instrumenting applications around observability signals. But most importantly, one specific solution that we heavily rely on is the OpenTelemetry collector. Now, what it does is it basically it's basically separated into different components. We have receivers, we have processors and connectors, and we have some exporters. Now, if you put this collector somewhere and you configure it with a specific set of receivers, a specific set of exporters, you could basically separate what's receiving, what's the receiving side of the signals, what's the exporting side of the signals, and the both sides become absolutely decoupled. For example, I had shown you this diagram right here. Any combination of receivers and any combination of log backends and actually log shippers could be handled using the collector. Using, for example, valitail and sending to Datadog, whatever you'd like. Any combination is feasible with the collector. And what has actually been achieved is this is the previous setup. We had a valitail on shoot nodes. It collected logs from the bots. It collected logs from the systemd units that we have, like the kubelet, for example. And then via the Loki API, it sent it directly to Vali in the shoot control plane. Now, what has been achieved is this part right here. The last time I gave the presentation, the collector that is now in the control plane had already been implemented. And now this PR I'm showcasing actually achieved this. It put a collector in the place of the valitail. And it basically does the same thing. Collects pod logs, it collects logs from journal-D for the systemd units. So it's basically nothing new. If everything is correct, you shouldn't even feel the difference. When you enter Plutono, for example, and you'd like to view some logs, should be set the same set of labels. Logs should look the same way. Maybe the only interesting difference is now what I've opened is what I've opened right here is actually a shoot node from a local setup I've started. You can see there's no valitail instance anymore if the feature gate is enabled. Sorry, forgot to mention, this is everything is behind a feature gate. And in the place of valitail, we actually have a new service, OpenTelemetry collector. And you can find the config of the collector here in Varlib OpenTelemetry collector. Now, that isn't really interesting. This is just the only difference that you might be able to see. What is interesting, and I'd like to show you, I'd like to give you a quick rundown on the difference between the configuration of valitail and the configuration of the OpenTelemetry collector. Now, again, the actual thing that valitail and the collector have to do is scrape pod logs from the specific directory that Kubernetes puts the logs in, and collect logs from the journal-D instance from the systemd units. Now, looking at the valitail configuration, to be honest, even now when I'm looking at it, I can't tell you exactly what it does and how it does it. I'd say it's pretty gross. I don't know if someone else has a lot of experience with the Prometheus style of configuration. Valitail, as a reminder, is just a fork of Promptail. Promptail Promtail Grafana, and Promtail relies on the Prometheus style of configuration. There's these jobs that do some relabelings so that the specific labels that we want get populated with the specific values that we want. There's a bit of use of regular expressions, which by itself isn't awful, but I wouldn't say it's great. And yeah, I'd say it isn't really readable if you don't, especially if you don't have experience with this style of configuration. Now, when looking at the collector configuration, this is it. Now it's not great. It isn't the best, but it's much better than the actual valitail configuration. In valitail, we had these jobs, and each job basically specified one set of logs that had to be scraped. Here in OpenTelemetry, we have these things called pipelines, and here we have two sets of, so we have two pipelines that are actually specified. So the journal pipeline that I talked about earlier and the pods pipeline. And this pipeline is basically just a set of receivers. So those are the things that know how to either receive logs or scrape the logs. And we have some processors that actually make some transformations on those signals. Then you have exporters that actually know how to send the logs outside to whatever has to receive them. It's pretty imperative. So, for example, if we'd like to see, okay, what does the file log pods receiver actually do, you could look at the, you could basically look at the configuration for it, and you could, even if you don't have the experience, just make some assumptions. So it's looking at a specific directory, it's using some sort of storage for some reason, and then there are some operators, I guess it does something on them. Or, for example, here in the processors, we can see the Kubernetes attributes processor, and you can look at it and you can see, okay, so it does some sort of filtering via the namespace. Then it checks some sort of label. You know, it's pretty intuitive, I'd say. And I'd like to show you this interesting tool that exists online from AutoBin. This is, again, the OpenTelemetry configuration, the same one that I showed you just 10 seconds ago, but this is just a visualizer of the pipeline. So we can see there are two pipelines. Here are the two pipelines. They have specific receivers. The journal pipeline uses the journal receiver, then it goes through a resource journal processor, then a batch processor, and then the Vox pods pipeline has a Kubernetes attributes processor, and so on and so forth. Yeah, that's about it. I just wanted to give you a quick comparison between the two configuration types. And that's it.
Cool. Thanks, Radoslav. Any feedback?
I agree on everything you said about the Promtail configuration.
Yeah, you agree, I guess.
Yes.
Yeah. I mean, I've looked at it so many times, and I could give you a quick rundown on what's happening, but I don't even have confidence in it even now after implementing the same thing in the collector as the valitail configuration. I don't know, maybe there are some fans of it out there, but I think it's really, really unreadable.
Yep.
All right, then I will continue with GAP 28 and the gardenadm Connect. So first of all, I want to mention that we have recently decided to rename the autonomous shoot clusters to self-hosted shoot clusters, so don't be confused. Actually, you can find some motivation in this PR. Background is that the hosted shoot clusters, so the traditional clusters we had, are coming from the hosted control plane naming in the community. So the natural counterpart is to self-host them if the control plane runs into the cluster. And that's why we have done it this way. And along it, we also got rid of these medium and high touch namings because they were not quite explanatory. Medium touch is now called managed infrastructure, meaning that there is a cloud provider API or some API where you can program the infrastructure and then also manage it. And high touch is just the unmanaged infrastructure case. So bare metal, edge, something where you have to manually manage machines and networks. Okay, then let's get back to the actual topic, gardenadm Connect. If you take a look at the Garden enhancement proposal, you will find this gardenadm Connects section here. So what is this about? This command is actually used to deploy a gardenlet into the shoot cluster. And the gardenlet should then connect back to the Gardener API and just watch the shoot resource that belongs to this cluster and reconcile it. But just like for hosted clusters, the concept is the same, just that this gardenlet is only responsible for exactly the cluster it runs in. And that's basically it. If you look at the issue, this was actually a series of PRs. So those that are here marked as completed. There were quite some prerequisites that we had to establish. For example, we also now have something called shoot authorizer, similar to the seed authorizer, because also the gardenlets running in these self-hosted shoots need some form of authorization and when they make requests to the gardener. And yeah, so all these things had to be established, and I will now show you how this works in a demo. So I have basically set up with the typical setup that you already saw in these meetings, a control plane machine. This is in a kind cluster. I ran gardenadm init here. You see the output. And now you also get some instructions here at the bottom, what you need to do if you want to connect this cluster now to an existing Gardener installation. And it tells you that we have to target the garden cluster itself and first create some bootstrap token. And with this bootstrap token, then we can connect it. So let's do that. It's again gardenadm token create. Similar to this print join command, there's also print connect command. And you have to specify the shoot namespace and the shoot name where this will be registered in the Gardener in the end. Because this token that is created here will then be exactly assigned to exactly this shoot. You cannot use it for some other shoot registration or for some other tasks. So we copy that against the garden cluster. And what we get is a fully copyable gardenadm connect command. We have a bootstrap token. We have the CA certificate of the gardener, and we have the gardener address. And we can copy that back to the machine. Before I execute it, I will also show you here in the Gardener API. Currently, there are no seeds, there are no shoots, but that's just an empty Gardener that is set up. And when I now run this here on the machine, you can see that it's ensuring the resources here in the garden cluster and is currently deploying a gardenlet into the self-hosted shoot. What we will then observe here on the gardener side is that this shoot manifest gets registered in the namespace with a name that we have also specified, that it has matched. If it doesn't match, this registration will be denied. And if we check the certificate signing requests, we also see that there are 2 new CSRs. This one is for the gardenadm connect command in order to create all the resources and ensure that they exist here in the Gardener. And this one is for the gardenlet itself. So the whole bootstrap mechanism works actually the exact same way like for seed clusters. So gardenlet creates the CSR, the Gardener controller manager auto approves it. Gardenlet gets a client certificate that is assigned to exactly the self-hosted shoot, and then also this authorizer can make educated decisions about the requests. All right, so this has completed. It tells us that the self-hosted cluster has successfully been connected. We can also delete the bootstrap token again if you want to. If we take now a look into the cluster, then we see in the cube system namespace, besides the usual system and control plane components, we now also have 2 gardenlet pods here. And let's see who is the leader, checking the logs. The other one. So you can see the usual logs when it starts up, when it bootstraps, when it gets some certificates and so on. And what we actually have done is currently for the development or further development of this scenario, we have disabled most of the logic in Gardenlet, so it doesn't really add any controllers except for this Gardenlet controller at the moment. This is used for self upgrades. I will show it in a minute. But there is no shoot controller yet and nothing else. We will now gradually add them one by one. And with that, then complete this whole thing. But we have to adapt it, of course, so that this fits for the self-hosted scenario. That's where we cannot simply enable them immediately. Okay, so as for this Gardenlet controller, again, same concept. If you have seen it before, it's not anything new. But there are so-called gardenlet resources in the Gardener API that represent a specific deployment of a gardenlet, usually in a seed cluster. But now we also have such resources for the self-hosted shoots. And if we check this, then we see this, for example, contains the version of the gardenlet that is deployed here, some deployment-related configuration like resource requests, but also gardenlet-specific component configuration. And if we want to update the gardenlet now, we can just edit this resource here. For example, I will increase the requests a bit. Can watch the pods. And if I save that, you will see that it's watching this and immediately updating itself, rolling itself out to a new replica set. And the same way, with the same approach, we could have actually updated the version or something else. So this is how we will make sure that these gardenlets are kept up to date. All right, going back to the issue, as said, the next step is to selectively check the controllers that exist in Gardenlet and see whether they can be added, how they need to be adapted. We have made a list here of the existing controllers. And the most critical controller is, of course, this one, which is then later responsible for the shoot reconciliation and shoot updates. This will probably be some effort, but some of them are also hopefully not so much effort in terms of adaptations. Okay, then the last thing, there was this presentation in the Apero meeting some weeks ago. There's a recording uploaded in the Gardener YouTube channel. They are still called autonomous shoots. Here we also explain a bit about the whole motivation for the work stream as such. We also have a demo that includes this connect command, but also some other things. So if you are interested, then feel free to check it out. And yeah, with this, I think I'm at the end. If there are any questions, feel free. Is the question, Vitran? Ah, okay.
Wrong button.
Yeah. All right. Then thanks for listening, and let's hand over to Lucas for the last topic for today, the metrics for the extension conditions.
Hi everyone. Unfortunately, I was not able to get my local setup up in time because I had another appointment right before the meeting. So I will just talk you a bit through what is now changed so that we can get a clear understanding of what is happening. So let me grab the pull request real quick and then we can go over it. Where is it? Okay, now I got it. Okay, so what we did is that we now have a new metric that is created based on the extension resource created by the Gardener operator. So if you are using the Gardener operator in your setup, you can now create alerts on a new metric called the garden extension condition. And this metric is quite similar to the one we introduced a few releases ago for the garden, so the garden condition. And with that, you can check whether your extension was installed already or is ready for installation, or if something is failing on any seed, and therefore you can alert based on that. So this is done through cube state metrics, as done before with the garden condition as well. So the cube state metrics runtime in the initial cluster will watch the extensions and report its metrics through it. So I guess from now we will introduce new metrics for the operator extension through this cube state metrics. So I guess we can still have a bit more to report metrics on. Yeah, and that's it. Sorry that there is no big demo today, but it's not that of a big change. You would just see a prompt QR query, so no worries. You can try it out yourself.
Yeah, cool. Thanks for still showing it. Then I guess there are no further questions. We are at the end for today. Thanks everybody for joining, and see you again in 2 weeks. Have a nice time. Bye-bye.
Bye. Thanks.
Bye. See you.